In the previous video, we talked about what happens when a series converges. It gets closer and closer to a particular value as you add on infinitely many terms. Now we're going to talk about what it means to diverge, which essentially means as you add more and more terms on, it gets bigger and bigger and goes off to infinity. Now this is kind of what we'd expect to happen with a series. And with this particular one, when we add 1 plus 2 plus 4 plus 8 plus 16, so adding the double each time, obviously the more terms we add, that gets bigger and bigger. It goes off to infinity. It doesn't get closer and closer to a particular value. It diverges. It never gets closer to a particular value. But this can get a little bit tricky with some sequences. So here we have a particular sequence which is not that different to the one we saw in the previous video. Instead of it being the powers of 2 in the denominator now, it's just the integers, so 1 plus a half plus a third plus a quarter plus a fifth plus a sixth, and so on. So we saw when the fractions halved each time, it got small enough, quick enough, that it converged to the value of 2. But in this case, actually, it diverges. And it can be a bit tricky to show this from many sequences and series. For this one, there's a nice little trick, and I will show you it. So what we know is that, or what we can say is this is most definitely bigger than something. We can say it's most definitely bigger than 1 plus a half plus, but instead of a third here, I'm going to write it as a quarter plus a quarter. So this one here, let's connect those two, has changed. And we know that this is definitely bigger than that one because a quarter is smaller than a third. So this sum is definitely smaller than the one that we started with at this point. And then we carry on, but this time instead of a fifth, I'm going to do an eighth, and I'm going to do an eighth instead of a sixth, and I'm going to do an eighth instead of a seventh, and I'm going to do an eighth for an eighth. So this time the fifth has become 1/8, the sixth has become 1/8, the seventh has become 1/8. And again, by the same argument, we know this sum has to be smaller than this one because we've turned 3 fractions into something that's smaller. And we keep doing that thing, so the next one will be a bunch of 16ths. And there's going to be a bunch of 16ths up to a 16th. And we keep doing that process. The next one will be 32ths. But the thing now to think about is we group these. Well, this is 1. This is a half. But this here is also a half. And this here is a half because it's 4 lots of 8s. And this here is going to be a half as well because that is 8 16ths. So this thing is going to be equal to 1 plus a half plus a half plus a half plus a half, and it's going to keep adding on a half each time. Now this we can see must diverge, because if we keep adding on a half, even though a half is less than 1, if we keep adding on a half, it will keep getting bigger, infinitely so. Quite slowly, but it will keep getting bigger, infinitely so. And because this one is bigger than this one must also diverge, it must also go off to infinity. We don't know what value this is going to be equal to because it diverges. It's not equal to a value. It goes to infinity. But we do know that it definitely goes to infinity because it's bigger than this one, which we know must go to infinity. Now, these kind of arguments can be quite tricky to spot. In the IB A&A higher level course, you're not actually expected to come up with these kind of arguments for looking at a series diverging. But when we come back to limits and differential equations, much later on in the course, we consider some of these ideas when we think about limits. It's not quite the same, but it is related. But this is just a brief introduction to how we can think about different series and the fact that some series diverge, go off to infinity as you add infinitely many terms, whereas other series converge to a particular value. And we will come back to that idea a little bit, in particular with relation to geometric series in Skill 5.